All right. Took a few moments there. All right. Hey, welcome back to the Caribou Data Science channel. This is the evening of, it's the evening of Tuesday, January 17th, 2023. On the agenda for tonight is more WorldQuant University's data science workshop labs. Uh, we're on the second module, and I think maybe the first or second lesson of that second module, which has a lot to do with like predictive models and then regression models and stuff like that. Nonetheless, folks, sit back and relax, and I'll see you back over in like 15 minutes. Hmm, that's interesting. Okie dokie, let's switch our regular thing here now. Let's see. So OBS worked fine last night, but tonight I couldn't get it to connect, which is kind of odd. But nonetheless, we'll just soldier on, as we say. And again, we're returning to, uh, see, it still has it connected here. So we're returning to the WorldQuant University's data science lab. Oh no, what a shock. There's missing cases. Wow, I can't imagine that. I can't imagine how that would happen. Okay, so anyway, what we're really interested in is models here. So we left off down here at around 2227, okay? So we left off in module one, loaded some library. We added some additional libraries, as you can see, scikit-learn impute, scikit-learn linear model, metrics, pipeline, utils, and we actually had a grading function here, but that's okay. Uh, Add to the wrangle function below that in the data frame, it returns longitude, latitude, column, replace that. So this, of course, we actually did this also in the previous lesson, or actually in the first lesson, I believe. Expanding out, splitting out by the longitude, latitude. Let's see, loaded a new library, loaded a new CSV file. Come on down here. Concat data frame 1, data frame 2, explore, complete the code below to create a match. Let me come back over here. And we created a plot. And we come down here, complete the code below to create a 3D plot. And that, my dear friends, is where we left off, okay? First, let's just come back over here. And this is where this adventure in data analytics started. It started with I'm not even sure how I found out about this channel. It may have been someone who follows me made a mention of it. I think that's what it was. I think someone just mentioned it in a chat session or something like that. The thing about this is it is completely free, at least so far. Uh, they don't ask for money, they don't beg for money. All you do is apply. There's a brief quiz, and the quiz is if I can pass the quiz, you can pass the quiz. Okay, and that's it. As you can see, there's actually two things. There's a Master of Science program. We're looking at the Applied Data Science Lab. Okay, so now let's come back over here. Go to Learn. Over here, Project. Of Machine. Okay, here we go. And we're actually using the Jupyter Lab notebooks. we're on 2. So let's just come down here, reload all of our data. Okay, nothing tricky there. Now we split out longitude and latitude. Check our frames. Now we're importing number 3. Check, check. Now we're doing the concat. Do a quick check here, sanity check, good. Now we're up to explore. And now we're getting close to our point here. So first of all, we create just the standard plot. Wait for that to run. And you see we've actually colored the spots by the price. Okay, so you come over in here. And as the instructor pointed out, the closer you get to the waterfront, the more the prices go up. Now we're come down here, we're going to do a 3D scatter plot. Main difference is, of course, up here, scatter underscore 3D. Height, width, so come over here. There it is. Honestly, I don't think that's much use. I think it'd be more interesting to do a 3D column plot, maybe. Yes, let's come down here now. I wonder where the heck that plot there. Oh, in the last lesson, we represented our sample model, simple model, as a line and posed on a 2D scatter plot, which is probably a much better representation. Okay. So we come down to the 227. And this is where we left off. Let's come back up here and do another. We actually did, as you recall, we actually did a split in the first module. Okay. Let's just watch this video here again. This is a reminder, a feature simply means it's a variable or a column containing data. Sometimes when you create new features, it's called feature engineering. But for our purposes, feature simply means a column containing data. We're creating a new variable or a new column of data. So this rascal has to say.
All right, last step in our data preparation. We've imported and cleaned our data. We've done a little bit of exploratory data analysis. And now we need to split our data into our big X and little y. So let's get started with that. We can see here that I've already given you all some starter code. So we know what our two features.
You say something? Okay. And again, this should look familiar to us because we actually did the exact same thing in another module.
Features are for xtrain. And in order to just turn xtrain into a subset those two features from our data frame, let's just do df and then square brackets and features. And if we look at xtrain.head, we can see that here is our feature matrix. If we look at .shape, we can see that it has two dimensions. So we have our 2,900 rows and then our two columns. So that is all working. Beautiful.
Okay. Okay. So do we actually have that over here as part of our, yep, there that is. So now we can move on, I do believe. Opening back since this is a markdown language, the opening and back and closing backtick says, format it exactly as you see it on here, okay? Normally, if you didn't do this, they would play everything on the same line. Okay, so let's come back over here. So let's create a target vector named yTrain, which you will use to train your model. Okay, your target should be price approximate US. Remember that in most cases, your target vector should be one dimensional.
The next thing we need to do is we need to do our little y, our target vector. So again, we have our target already predefined for us. So it's just an issue of putting in df, square brackets, and then target. And I can just do ytrain.head to check myself. Beautiful. This is looking good.
Good.
I love it. And if I look at shape, I should see that it's only one dimension. Same 2,900 rows. Awesome. Ready to go.
That takes care of 8. Now, whether or not this will make sense in the mornings is, of course, is a question, but that's okay. Again, we need to set a baseline so that we can evaluate the model's performance. You'll notice that the y mean is not exactly the same as it was in the previous lesson. That's because we've added more observations to our training data. Okay, good.
Data preparation, it is done. So now let's start building our model. In the last lesson, we talked about baseline models. And so this time what we're doing is we're building our muscle memory. So this is a regression problem. We're still predicting the price of apartments. And so the first thing we need to do is we need to get the mean of our training data. Let's zoom in. And that's going to be ytrain.mean. Beautiful. So that is done. And then we need to create that list of
Good.
predictions where everything is the mean over and over again. And so for that, we'll do square brackets with y mean inside, and then we will multiply that by the length of our training set, which is ytrain. And if we just take yPredict baseline and paste it down here below, we should just see that
All right.
same number over and over again. Beautiful. So here's our 138,000 over and over again. Okay, we've got it. We've got it. We're rocking and rolling. So let's keep going.
Hey, how you doing, friend? Can you maybe say a few words when you put in a new command for when I'm not looking at the screen. I can see what I can do about that. Although basically all I'm saying is what's on the screen itself. Uh, so I'm basically I'll see what I can do for y'all. Okay. Anyway, so we're trying to we're going to our second round of models here. Uh, you've added some additional features. Feature being just new variables, new columns of data, or stuff like that. Okay. Probably should have used something besides that there. Okay. We came down and it's now up to 2.2.11. Calculate the baseline mean absolute error for your predictions in your Y predict baseline as compared to the true targets in train. So there's our baseline. That's sort of what we're actually going to. This is the expected values. So we're going to compare the actual values to the baseline. I believe way that works is. There that is. By the way, you can get all my notes from each session. So you can download all my notes from there. Okay. And basically, all I'm doing is I'm cutting I'm cutting and pasting the code chunks into my notes, and that's really all that is. Just a reminder that this course is completely free. I mean, when I say completely free, I mean completely free, at least so far. I mean, there was they didn't ask for any money up front. They didn't ask for any money whatsoever. You simply go take take the quiz, pass the quiz, then you get to take the course for free. Okay. And again, this consists of 8 different modules. Each module consists of 4 or 5 lessons. Each lesson ends with like a 1-question quiz, which is a code quiz, and then you move on, and then you get graded, and you move on to the next. Okay. So this is a brief recap. The first module was an introduction to basically doing exploratory data analysis using Python and Pandas. Uh, in beginning with module 2, we began looking into various predictive model methods. Particularly, we're looking at linear regression methods here so far. I don't know. It's a very good question. I honestly don't know. Uh, I mean, it doesn't say anything about it on there. Well, let's just take a look over here. The website again is says WorldQuant University. Okay, WorldQuant University, wqu.edu. Start application, tuition free, leverage real world data, access all the tools you need, guides by your side, develop skills to build a professional portfolio, uh, credentials, shareable. Yeah, here you go. Uh, Shareable Credly certification. Credly, I don't know if you're familiar with Credly. Credly's kind of like a uh, to a certain extent, it's sort of uh, it's sort of like a verifiable, certification. But the main thing is here. This is what most people say is more important. This here A lot of people would say it's more important than the certification because it's easy to get certifications online. Okay, and so so they say, the key to getting your job is a data is a data analytics online portfolio. Of course, the problem with that is recruiters and employers still that's nice, but in my experience is that recruiters and prospective clients and employers still want to see a resume. Okay. So anyway, let's come down here now. So anyway, this section is 2 point goes up to task 2.2.22. Where are we? We're at 2.2.10. Okay, so we're back up here. So we have what, about 10 more sections to go. All right. And so here we are right here. We're at 2.10. Now my so are we all tell me your background. I can't remember what your background is. What's your background? 2.2.11, calculate the baseline mean absolute error for your predictions uh, in the Y predict baseline as a comparison to the true targets in Y train. Okay. Let's take a look at this here then. Mean absolute error. What's mean absolute? I don't know actually. To tell the truth, let's see what it says here.
And for this task, we need to calculate our baseline mean absolute error. So we've already imported mean absolute error from up above. So it's just an issue of then in here putting in our Y train on the one hand, and then our Y predict baseline on the other hand. Beautiful. And if we hit Shift and Enter, we see what we saw in the last lesson. If we were to predict for every house that it cost $138,000.
Okay, so we can come down here now. Mean absolute is a built-in function. It's part of scikit-learn, I believe. Mean absolute error. Okay, performance metrics. So here we go. See, in statistics, an error is a difference between a measurement and reality. There may not be any difference at all, but there's usually something not quite right, and we need to account for that in our models. To do that, we need to figure out the mean absolute error, MEA. Absolute error is an error in a single measurement and means absolute error is the average error over the course of several measurements. Imagine that you're buying some bananas. Ramula. Oh, what's this guy doing? Nick one. Nick one is moving apparently. Oh, and I also see that Medallion Stallion is going to be streaming here shortly on it's going to be streaming shortly here on Twitch. Anyway, imagine that you're buying some bananas. A store charges for fruit based on weight, which is true. So you put your bananas on the scale before you head off to pay for them. The scale says they weigh 1.2 kilos, but your innate sense of weight says, yeah, they actually weigh zero point 0.9 kilos. The absolute error in that measurement is zero point 0.3. So the mean absolute error is the difference between the actual value, the actual measurement, and the yeah. So the mean absolute error is the difference between, we might say, the recorded value and the expected value, right? All right. All right, good. So let's come back over here now.
1,000, we would, on average, be off by about 50,000.
Okay. So we have 2 to 11 over here. 2 to, yep, we do. So tell me, Rial, what are you up to today? So, so the mean apartment price is what? That's the price. So this is actually the weight of the bananas, so to speak. This is the actual measured value. Okay, and the mean absolute error says there's a difference between. Let's read this again over here. Let's see. In statistics, the error is that there's a difference between the measurement and reality. So sometimes I think the difference between getting the job and not getting the job is to is knowing all the jargon and the buzzwords to say during the interview. But anyway, yeah. So I wonder what that crazy an error is the difference between the measurement and reality. Any difference, but between what the actual value is. So the actual value is 100. The actual value the actual mean price is 134,000 plus. The baseline says it's 45. The mean absolute error says it's 45,200. And statistics is the difference between the measurement and reality. There may not be anything, but there is usually something not quite right, and we need to account for that in the models. To do that, we need to figure out the mean absolute error. Absolute error is an error in a single measurement. Okay, and the mean absolute error is the average error over the course of several measurements. So the average of all the mean absolute value is the average. Now, imagine you're buying some bananas. The store charges for bananas based on weight. So you put the bananas on the scale before heading off to pay for them. The scale says they weigh 1.2 pounds. So this would be the average apartment price. But your innate sense of weight tells you that they're actually 9/10 of a kilo. The mean absolute error in the measurement would be 3/10. Okay. So over here, the mean absolute error, well, this says, so this is the difference between the actual mean and right? Okay. The absolute error in that measure would be 3/10 of a kilo. It, it can go the other way too. Uh, Maybe you know the bananas weigh 1.2 kilos, but the scale says a 0.9. In that case, the absolute error would still be 0.3 because even though the numerical difference is minus 3/10 a kilogram, values are always positive. Let's keep going. Okay. uh, let's keep going. You're sure the measurements weigh 1.2 kilos, so you weigh them again. This time the scale says it's 1 kilo. Well, that's still wrong. So you weigh them a third time and you get 2.3 kilos. Since the actual weight of the banana that hasn't changed, you now have three sets of absolute errors. If we average these errors together, it's 6/10. And this is the mean absolute error is the average of all the measurement of all the. Okay. So let's watch this one more time.
And for this task, we need to calculate our baseline mean absolute error. So we've already imported mean absolute error from up above. So it's just an issue of then in here putting in our y train on the one hand, and then our y predict baseline on the other hand. Beautiful. And if we hit shift and enter, we see what we saw in the last lesson. If we were to predict for every house that it cost 138,000, we would on average be off by about 50,000.
Okay, good. That's much simpler to understand. This is the average actual price measured. Mean absolute error says we're actually off by this much per house on average.
I don't know. I'm just trend setting. I'm into early adopting. Early adopting means that you don't have to like jump on trends that don't amount to anything. You get all the benefits of jumping on stuff. Pog Deflin's up at 3 a.m. Get to bed. Why are you watching me? I'm not that entertaining for you to skip out on sleep, unless that's just the way you roll. And if it is, hey, I'm happy to have you with me. All right, we're gonna pip install this YT Whisper. Error, could not find a version that satisfies Whisper, unavailable from YouTube Whisper. Well, that is gonna be a problem.
Okay.
What's the requirements of
So again, this is the average price that we were given. This is how much on average. So these are the actual prices. So the mean absolute error is the difference between the predicted price for each apartment and the actual price per apartment. So we're saying that what we're really saying is probably this is 45,000 too high. Okay. Okay. Take a moment to scroll up to the output of DF info and look at the values in the null not null count now non null count column because of the.
So let's go ahead and
I'm going to turn
this.
old.
Hopefully you guys can see everything okay. Let's see how my system's doing as this runs. All right, so YouTube Whisper, what I believe is
Okay. Take a moment to scroll up to the output of DF info. Well, better yet, let's just come over here. Okay. Okay. Itinerant. So scroll back up. Look at DF info. Look at the values in the null not count. Null not null count. Okay. So you can see most of these are pretty consistent. There's one. The surface title has a. old medallion stallion's a wild and crazy guy. Uh, let's get rid of this up here first of all. Okay. Now, not null count column. Because of the math it uses, a linear regression model can't handle observations where there are missing values. Do you see any columns where this could be a problem? Sure. Anything less than 2,658 is a problem, right? So surface total in square meters is wrong. Price unit per square meters is wrong. Floor is wrong. Rooms is wrong. All right, very good. So now we get on to imputation. Imputation, that's right. Now, if I come over here, okay, it's getting close to mincemeat pie time. All right. Iteration, we're now getting into what's called imputation, which is the way you which is used to replace missing values. Okay. Now, do you see any columns where this will happen? Now, in the last project, we simply dropped rows that contain null values. But this isn't ideal. Modules generally perform better when they have more data to train with, so every row is precious. You know, I could use this over on Kaggle with the data set I was working over there, which had all kinds of missing values. Precious. Instead, we can fill in the missing values using information we get from the whole column. The process is called imputation. There are many different strategies for imputing missing values, and one of the most common is filling the missing value with the mean of the column. In addition, the predictors like linear regression, scikit-learn also has transformers. Transformers to help us deal with the issues of missing values. Let's see how this works, and then we'll add it to our model. Okay?
As we begin to build our model, I think it would be helpful to kind of visualize what's going on. So let's start with our data. So this is my big X, my feature matrix, and then this is my little y, my target vector. And what I want to do, what we did last time, is we took that data and we dropped it into, let's call this a predictor. Now, in the last lesson and in this lesson, our predictor was linear regression.
Mm-hmm.
And the idea is that we took this data and put it into that predictor to train the model so that it could make predictions. All right, so that's what we have so far. But, there's always a but with me, right? What if something happens where this data can't be put into this predictor. There's some sort of problem with it. What do we do? So let's go back to the notebook and let's scroll down to the part where we're supposed to be iterating. There we go. And let's open up a new cell here. Let's open up a new cell and scroll in. Now, if we were looking at X-train, actually, let's do it this way. Let's say I have a model. My model is linear regression. I have it as the defaults. And then I do model.fit, and I do X-train and Y-train. And let me make that a comma, not a period. Now, if I try to run this cell, what you see is I get a value error. And if I scroll down through all of this error stuff, it's going to tell me that the input, the model that the data that I'm using to train this model contains NaN, or missing values, not a number values. And since when the fitting happens, there's like math going on underneath, there's that ordinary least squares regression thing, it's not going to be able to do that math with missing values. And so what it's saying is I can't train myself because of the way the data is. So you need to do something about that data. So this is the problem that we're hitting. And if we scroll up here to our original text, our original code that threw the error, if we look at xtrain.info, we can see that even though we have 2,600 observations, there are only 2,500 non-null rows. Non-null rows. Say that 5 times fast. So what that means is that we have about 100 rows or observations where there are missing values in our data set. Now, last time we dealt with missing values by just dropping them. But that's not always the best choice. Why? Because sometimes those rows, especially when we start dealing with a lot more features, can have valuable information in them. So the question is, what do we do? And the answer is we need to transform our data before we put it into the predictor. And in this case, we need to fill in those missing values or X, my feature matrix, and then this is my little y, my target vector. And what I want to do, what we did last time, is we took that data and we dropped it into, let's call this a predictor. Now, in the last lesson and in this lesson, our predictor was linear regression. And the idea is that we took this data and put it into that predictor to train the model so that it could make predictions. All right, so that's what we have so far. But, there's always a but with me, right? What if something happens where this data can't be put into this predictor? There's some sort of problem with it. What do we do? So let's go back to the notebook and let's scroll down to the part where we're supposed to be iterating. There we go. And let's open up a new cell here. Let's open up a new cell and scroll in. Now, if we were looking at X-train, actually, let's do it this way. Let's say I have a model. My model is linear regression. I have it as the defaults. And then I do model.fit, and I do X-train and Y-train. And let me make that a comma, not a period. Now, if I try to run this cell, what you see is
Kaggle for about like 4 or 5, like really like 3 or 4 years competitively. I did it for like 2 years really competitively.
Okay. So that message there is pretty clear.
I get a value error. And if I scroll down through all of this error stuff, it's going to tell me that the input, the model that the data that I'm using to train this model contains NaN, or missing values, not a number values. And since when the fitting happens, there's like math going on underneath, there's that ordinary least squares regression thing, it's not going to be able to do that math with missing values. And so what it's saying is, I can't train myself because of the way the data is. So you need to do something about that data. So this is the problem that we're hitting. And if we scroll up here to our original text, our original code that threw the error, if we look at xtrain.info, we can see that even though we have 2,600 observations, there are only 2,500 non-null rows. Non-null rows. Say that 5 times fast. So what that means is that we have about 100 rows or observations where there are missing values in our data set. Now, last time we dealt with missing values by just dropping them, but that's not always the best choice.
Okay, so we're beginning to use simple imputer, which is a function within the scikit-learn, I think. And now that within that function, we're using something probably called imputer. And if you look here at the info, as he says, for the xtrain, you see that there's 260. We can say that there's 2,658 rows of data. Okay, but only 2,000 for latitude and longitude. There's only 2,561 non-null values. Okay.
Why? Because sometimes those rows, especially when we start dealing with a lot more features, can have valuable information in them. So the question is, what do we do? And the answer is, we need to transform our data before we put it into the predictor. And in this case, we need to fill in those missing values or impute them with some other value. Now let's go back here to that whiteboard. And we were talking about problems. Well, what we now need to do is we need to add another component here to our workflow. So I'm going to just erase this first part. And what I want to do is I want to create another component here. And I'm going to call this T for transformer. So we have a transformer and then a predictor. In this case, the transformer is going to be an imputer. We'll talk more about what that does in a second. So now our workflow is we're going to take our data, we're going to put it into the transformer. It's going to come out of the transformer in another form. Let's call it X sub T for transformed. And then we put it into our predictor, and then it should be able to work. All right? So we going from transformer to predictor. Transformer, transform data to predictor. Now, one thing that I want you to keep in mind is that usually when you're building a model in scikit-learn, you take your transformer and your predictor and you put it together in a single package called a pipeline. And we'll learn more about that in a sec. But what I want to do right now is just to make an imputer, or just work with one example of an imputer by itself, so you can get a sense of what's happening kind of under the hood. And then you can take that appreciation into your model building when you create that pipeline. So let's take this back to the notebook here. And before we build our transformer, just a word to the wise, the distinction that I'm making between predictor and imputer, that's not really how the code is implemented in scikit-learn. These are actually very similar classes. And so while this is a useful kind of mental distinction for you to kind of visualize what's happening on, there's not a lot of difference in terms of code. And that's good news because that means that working with imputers is a lot like working with predictors. And so the things that you learned in the last lesson are really important here as well. So going here to the notebook, if we're going to create our imputer, the first thing that we do, just like with a predictor, is we need to instantiate it. So I'll do simple imputer. I'll put my open and close parentheses here and hit Shift and Enter. And that's it. I've instantiated my predictor.
Wait a second here. Wait a second. That.
I've instantiated my transformer.
Okay. Okie dokie. All we're going to do there is come back over here. Now, all these little work checks is kind of interesting. Just like a predictor, a transformer has a fit method. In the case of the simple imputer, this step where it calculates the mean values for each numeric column.
Remember that transformers in terms of their syntax are almost identical to the way predictors work. So a lot of the code we learned is going to apply here. So I've created my imputer, and the first thing I need to do is I need to train it. Now, why do I need to train it? Well, what's going to happen is our imputer is going to look at each column in our feature matrix that is missing values. It's then going to fill in those missing values with whatever the mean of that column is. So it's going to calculate the mean of each of those columns. So that's the training that's going to occur. And in this case, it's just an issue of doing my imputer and doing fit, the same way we work with the predictor. And I'm only going to pass in my feature matrix since that's the only thing I'm transforming. So just the feature matrix here. So I'll hit Shift and Enter, and then I will check my work. And now I'm ready for the transformation. Remember that transformers in terms of their syntax are almost identical to the way predictors work. So a lot of the code we learned is going to apply here. So I've created my imputer, and the first thing I need to do is I need to train it. Now, why do I need to train it? Well, what's going to happen is our imputer is going to look at each column in our feature matrix that is missing values. It's then going to fill in those missing values with whatever the mean of that column is. So it's going to calculate the mean of each of those columns. So that's the training that's going to occur. And in this case, it's just an issue of doing my imputer and doing fit, the same way we work with the predictor. And I'm only going to pass in my feature matrix since that's the only thing I'm transforming. So just the feature matrix here. So I'll hit Shift and Enter, and then I
Not fix. Yeah.
Magnitude more popular than me. He's been doing videos for years and years. So I am honored to be put in the same sentence. And for you to think that I am like he's copying me or something. I don't know if that's what you intended.
So our goal is to try to finish this lesson here tonight.
I will check my work, and now I'm ready for the transformation.
We did this. Okie dokie. And we'll just check our work. Of course, there is a possibility that tomorrow these notes may mean that absolutely nothing to me.
I've instantiated my predictor, I've fit it to my training data, and now it's time to actually transform that training data. So when you're working with predictors, you usually do .predict. If you're working with transformers, you do .transform. So I'm going to take my imputer, I'm going to do .transform, and inside, I'm going to say I want you to transform xtrain. And then I'm going to assign that to the New variable xt train, and that's for x transformed. And if I hit shift and enter, what we'll see is, well, first I get an attribute error because there's no transform method. So what I actually need to do is spell transform correctly. I'll then hit shift and enter, and what we'll see here is that whereas up above we saw that we had missing data, these were right at around 2500, you can now see that they've been filled in. So now my data is ready to move into my predictor.
Okay, so let's see what happens down here. Right. So this means there's now no missing values. Very interesting. Okay, good. Now, okay, our data is free of missing values, and we have a good sense for how predictors work in scikit-learn. However, the truth is you rarely do transformations this way. A model may require multiple transformers, and doing all these transformers one by one is slow and likely to lead to errors. Instead, we can combine a transformer and a predictor into a single object called a pipeline. Let's see what this RAS class is say here. Build a pipeline. So what do we do when we have to do more than one pass for the imputation? That's the question we'll answer now.
Okay, time to build our model. And like I said, most of the time you don't have transformers and predictors apart from each other. Usually you put them together in a pipeline, which is what I have here. So to build our model, why don't we create a pipeline? So going to the notebook here and zooming in, I'm going to create my model, and I'm going to start with just doing make pipeline. make pipeline. After that, I'll do my open and close parentheses, and I'll hit Shift and Enter just to have a little bit of space. Next, I just put in the different steps of my pipeline. I put them in sequentially. So first, I'll put in my simple imputer. So I'm creating a new simple imputer here. And then after that, I'm going to put my linear regressor. So linear regression. Regression. I'll use tab complete. There we go. So these are the two steps. One thing to point out, you can have as many transformers as you want in a pipeline, just one after the other. But you can only have one predictor, and it needs to come at the end of the pipeline. So that's that part of the model that actually does the training and the predicting. So one predictor at the end. All right, beautiful. So as soon as I hit Shift and Enter, I've now instantiated my model. I can check the assert statement, and it looks like it didn't throw an error, so I'm good to go. And the next step would be then training the model.
Okay. Now we're going to create the pipeline using the make pipeline command. Add the simple. So we have a two-step pipeline. We use it. So we put inside there. We put the function call for simple imputer, and also the function call for linear regression. Okay. Let's see what happens now. That appeared to work. What do we say? 2.22 sections. We're up to what? 2.28 or something like that? Or 2.5. Okay. 2.6. Now we come down here to this video right above 2.2.16. Mm-hmm. Train the model.
Okay, time to fit our model to the training data. So I'll start with model, and I'll do fit, and I'll do xtrain and ytrain. And if I hit shift and enter, take a look at the output here, because this looks different to the model that we created last time. Notice that instead of saying linear regression at the beginning, it says pipeline. So this is a pipeline object. And then inside this pipeline, it has steps. Now, each of these steps is given as a tuple, and the tuple has two parts. The first is a name that's given to each step. In this case, it's just like all lowercase, it's just a string. And then the second is the actual thing, the actual object. So this is the actual transformer object This is the actual prediction or predictor object. So now our model is a pipeline, and inside that pipeline,
So again, it's mod model dot fit x train y. Okay. It's interesting that the output from these commands in some cases is actually a little different from what he has up there. It's just sort of interesting. Not quite sure why that is. There we go. Okay, we're getting close to being productive here. Evaluate. Okay, good. Now I'm going to do an evaluate section. Okay, as always, we start by evaluating the model's performance on our training data. 2.2.17. Okie dokie.
all right, let's make some predictions. So I now have my model. So I'll do model.predict. There we go. And inside there, I'll put in my feature matrix, and I'll hit Shift and Enter. And then I'll see if I pass my assert statements, and indeed I do. I now have 2,600 predictions. So let's calculate our mean absolute error.
Now, I must say these sections here are moving along pretty quickly.
We have our predictions. Now let's look at our mean absolute error. So we'll do mean absolute error, and we'll do y train, and then for our prediction, we'll do y predict training.
Say what?
We have our predictions. Now let's look at our mean absolute error. So we'll do mean absolute error, and we'll do y train, and then for our prediction, we'll do y predict training.
Mean absolute error is 42,000. It looks like our model performs a little better than the baseline. This suggests that the latitude and longitude aren't as so strong a predictor of price as is. Interesting. Okay. Okay. We're getting close to the end here for the session. Hmm. This is interesting. Now let's check our test performance. Remember, once we test our model, there's no more itinerations allowed. That's interesting. Okay. Run the code below to import your test data, Buenos Aires test features, into the data frame. Create a series of predictions using the model. Then run the following cell to not sure about that one. We'll take this code here. Hmm. Okay, so this is the kind of little pop quiz here. We didn't really do anything up here, did we? What we did, we converted it to a series, okay? And we imported X test. Remember, we had training data and test data. So once we run this here, we can't go back and do it again, right? Is what it says? Test our model. There's no more itineration. Why not? In that case, you probably should run more itineration to get it even closer. Okay. So we passed that quiz. which means we're like really, again, we want our test performance to be about the same as the training performance, but it's okay if it's not quite as good. Well, what our last number up here is what, 42? So it's about 6,000 off. Okay, 6,000 high. And we're getting close to the end. Let's just come over here. Did you say instantiate? Okay. Let's take a look at our equation our model has come up with for predicting the price based on longitude and latitude. We need to expand on our formula to account for both features. Extract intercepts and coefficients.
Do you guys remember this equation from the last lesson? In the last lesson, we were looking at apartment price, and our x here was area. And the two coefficients, we had our first coefficient that was the intercept, and the second coefficient that was the coefficient that was like the slope of our line. Now things are getting a little bit more complicated because we don't have just one feature. We don't have just one feature here, which is area. We now have two features. So we have x1, and then we also have x2. And the first one is latitude, and the second one is longitude. So what that means is that our equation becomes a little bit longer because we don't just have one set of coefficients here. We add a plus, and then we need to add another beta right here. There we go. So we have beta 0, beta 1, and beta 2, and those work with the intercept, latitude, and longitude respectively. All right? So let's take this idea and begin pulling out these pieces of information from our model so that we can share them with our colleagues. I'll go to the notebook here, and we need to pull out the intercept and coefficients. Now, things are going to get a little bit different than how we did them the last time, because remember that our model is no longer like a single object. It's no longer a linear regression predictor. It's a pipeline, and inside that pipeline, we have the transformer and then the predictor. So we need to go inside the pipeline, find the predictor, and then pull out the intercept and coefficients. So the way to do that is you start with your model, and then you use what's called the named steps. You use named steps, and this is kind of like a dictionary. So we'll use square brackets, and inside square brackets, I'm going to start with the name of the step that I want. Remember up above when we were looking at those tuples in our model? Actually, let's scroll up and take a look. Here we go. So the keys for our models are right here. This is the name of the step that we want. So I'm going to copy that. I'm going to scroll down. There we go. Beautiful. I'm going to zoom in. And so I'll do named steps, linear regression, and then I can do coefficients. And I'll do that underscore, excuse me, not coefficients, intercept, right? Beautiful. Intercept. And let's just print out intercept to make sure that it's exactly what we want. There we go. We got a number, a big number, but it's a number. All right, beautiful. The next thing we want is we want our coefficients. So we'll do the same thing. We'll do model dot named steps. And then I'll open up some inverted commas. I'll use tab complete. I think it will just give me the name. No, it looks like it's not even going to give me the name here. So for name steps, I'm just going to go again to linear regression. There we go, linear regression. And I'll do coef to get those coefficients.
Okay. The code for pulling out the intercept and coefficients is model dot named steps let's back up here. Underscore. Let's just try something. bunch object is not callable. Let's get rid of that. Copy this.
And then let's just print them out to make sure that it's what we want. We should see two different coefficients. And we have an array here, which is kind of like a list. And we have our two coefficients. So we now have all of the components of our model. And you know what? Let's also do something else here. Let's take this and let's make these a little bit easier to read. I'm just
you know, the thing about these, the thing about uh, errors here, if you watch the videos, sometimes there is a little difference between the way something's displayed. The output's a little different than what happened when we're actually running that code in these windows here. Because this is probably using the, I don't know, well, if it's Jupyter Lab, if it's actually online and not on their own servers, it could be running a slightly later version of, scikit-learn and stuff like it, just like the chat AI said. Okay, but so anyway, we're going to see if it's possible to get past this point. Yeah, empty expression not allowed. So this is kind of annoying. But I have a hunch, and probably not the only one that got this here. I'll be right back in one moment. Just give me a second here. Well, I have a hunch, okay, that I'm not the only person who had this problem. Okay, uh, if we all use the same version of Jupyter notebooks in Python, right, then we should all get the same error. I mean, remember, everything up to this point ran without any errors. So there was a problem someplace else in the data. It could be kind of hard to find. So what we can do is we can go back to the forum, search for this task or search for this bunch error. Okay, see what other people come up with. Is there something I'm missing here? So let's come over to here and do this. Now, come back over here, over here, over to here, forum. Can I use this to search the forum? How do I search? Good grief, they're right. It does have square brackets. Let's try this again now. There we go. So the correct answer is what? The correct answer is square brackets, not round. Now, I must say, to a certain extent, sometimes it's kind of hard to tell whether a bracket's round or square. But okay, but here's the thing: almost always, I think in Python, it's going to be square bracket because that's how you kind of separate the columns. Let's just come down here then. Let's take a look at these two numbers, shall we? So, my friends, we're almost to the end of our show. We're almost finished up with 21. What's this one over here say? Let's see. Price and neighborhood, path. Okay, good. this. Remember, almost always in R or in Python, you're going to wind up using square brackets. Does F mean raw? We usually use print to reference output in Python, but most of them, by the way, we're almost to the end of this lesson or to this workbook, or because remember we started at 21, it goes up to 25. We're now working on 022, wrapping up 022. Using print to examine output in Python, but most of the examples we've seen printing have been relatively short. Okay, formatted strings are useful for all sorts of reasons, but when we're assembling and formatting long strings, using the print function can be difficult and time-consuming. Along with along the same lines, it can also be useful to directly evaluate variables and expressions within strings. To do these things, we create F strings. Import date time. Python birthday date time. This F. Python first appeared on Python birthday in the year Python birthday. Okay, so the F function is just it's a way to better format data, I guess we could say. Always remember, they'll always give you the answer to the problem. All right.
Just on the end of here, I'm going to do round to 2 and round to 2 so that we only round it to 2 decimal.
That's 221. You know what this means, my friends? We may wrap up this session this evening because this is all we have left to do. So, Rahul, are you still there? Okay. And so, my dear friends, once we finish up this 222 here, that wraps up 0.021. All right.
All right, we have the equation for our model. How do we visualize it? Remember when I asked you, what did you think? How are we going to visualize this model? So let's see how it goes. I'm going to use a 3D scatter plot here. Let's zoom in, and this will basically be what we filled in up above. I'll put in longitude for X, and then I'll put in latitude for Y, and finally, and I'm going to copy and paste this from the instructions up above right here, just so I don't mess it up. There we go. I'll copy, and then I'll paste it in here. We'll have Z being our price approximate USD. Now, I'll go through all of this separate code in another video because it's a little bit outside the scope, but it's a fun deep dive. So we'll just keep that in mind. All right, so let's run this code. I'll hit Shift and Enter and zoom out just so we can kind of see what's going on. And look at this. What we've done is we've combined kind of the two visualizations that we did into one. We have latitude, longitude, and price. And whereas before, let me zoom in. Whereas before, our model was represented with 2 dimensions as a line, now that we have 3 dimensions, we extend that line into the 3rd dimension, and so we get a plane. And what this plane is showing us, if I kind of move things around a little bit, let's see here, there we go, there's that triangle again. And what we can see is that as you move east, property gets more expensive. And the reason is because as you move east, you get closer to the coastline. Now notice that this doesn't exactly follow the data the way we want it to. We would really love for it to almost, this plane to be going diagonally. But that's kind of a little bit of a limitation born out of the fact that we're dealing with that linear model and it's only going to work on those straight lines, on those grid lines. So that's what's going on here. But long story short, what we have is we have a model, and that model in this case, where we have two features and one target, our model is a plane. You've made it to the end of lesson 2. Congratulations. So what are the two big things we learned today? The first is, if you have data that is problematic, like say you have missing rows, you don't need to just throw them out. You can use something that in scikit-learn we call a transformer to change your data, to transform your data in such a way that you can use it to train your model. And in scikit-learn, we learned that you start with your transformer, then you have your predictor, and you package them together in what we call a pipeline. The second thing we learned is about linear models. So when you have linear models in 2 dimensions, just one feature and one target, you can think of it as a line. But when you add another feature, so I have 2 features and one target, all of a sudden I'm not in 2 dimensions, I'm in 3 dimensions. And so my 2-dimensional line becomes a 3-dimensional plane. And you can imagine that this expands and expands as you add dimensions to it. But the important thing to remember is that even though we're in another dimension, our linear model is working in the same way. So it's always thinking in terms of straightness, straight lines, straight planes, and it's always concerned with distance, trying to fit the data, get as close to those data points as possible. So keep that in mind, and then in the next lesson, we're going to add more features and see what happens to our model. All right, we have the equation for our model. How do we visualize it? Remember when I asked you, what did you think? How are we going to visualize this model? So let's see how it goes. I'm going to use a 3D scatter plot here. Let's zoom in, and this will basically be what we filled in up above. I'll put in longitude for X, and then I'll put in latitude for Y, and finally, and I'm going to copy and paste this from the instructions up above right here, just so I don't mess it up. There we go. I'll copy, and then I'll paste it in here.
And that, my dear friends, concludes this module. Or conclude what you want to call it. Let's just call them chapters. The whole course is a textbook, and each section is a you know what I'm trying to say. That's the final note for tonight. All right, let's close that. So now we got a wrap here, right? Let's take a peek at this next one down here. Predicting price with neighborhood category encoders. That's something new. split. So we are slowly running out of wrangling here to do, I think. So this one goes all the way down to 2316. So it actually is a little bit shorter. Bar plots, create bar plots using pandas. So the next section, doing something a little bit. What is overfitting? What is regularization? What is ridge regression? Stuff like that. Okay. Make sure we're not missing anything over here. Interesting. Just having a couple minutes to load Twitch. Let's just watch a little bit of the old Rob Mueller, the Medallion Stein here on YouTube, shall we?
Version or like translation, but we'll have to see that. The chat ready to display messages. Oh wait, can I ask for advice before you start your project? Viodis, yeah. Go for it. Ask away, sir or ma'am. All right. So while you're asking, I'm gonna go ahead and get set up here in my environment. So it looks like maybe I need to create a new environment. Let's just start out clean and new and fresh. Nice and clean.
Yeah, so I'm trying to use a little. It's a it's a light version of Linux called Puppy Linux. You can install it in as little as, I mean, a gigabyte would be more than enough space to be started. I think it actually installs at about like 500 megabytes or something like that. May be too high also, but anyway, I installed it into a virtual machine, and I was able to update Python using the package manager up to 3.6. What we're really looking for is what yeah, 3.10. So the package manager could go up to 3.6. I want to go up to 3.10.8 because part of the problem is that that I can't use pip with 3.6. Okay, but outside of that, I mean, it's a small Linux system. What we got here? But it's and it'd be kind of fun to actually use some Python programming on it maybe or something else. I mean, I should for instance be able to use it to access the our lessons on WorldQuant University. So that's what that is. I did have a full blown Ubuntu. Uh, it seems like I can't do without Linux. Even if it sits on my desktop and never gets used, I still have to have it installed. It seems like I thought, I'll save a bunch of space. I'll uninstall the full Ubuntu 20.0.4 from the system. It probably saved me 100 megabytes, maybe as much as a gigabyte. So saved a little space that way, but I still want to have that little taste of Linux every now and then. Okay, let's just see what the old Medallion Stein has to
And
say here.
fresh with a new Conda environment. We'll Conda create, um, and we'll name this YT Whisper, and we'll do Python equals 3.8. I think they said 3.7 or greater, newer here, and I'm pretty comfortable with 3.8. Oh, and don't do that backslash. And we're going to create this new Conda environment in which I will run
Pandas
YouTube
for
Whisper
wimps,
in.
by the way.
What's my favorite anime? I've never gotten really huge into anime. So, is it the same as assembly.ai? No, I think those two are different. So I want to do something with this data set, but I can't come up with anything other than displaying top 10 stats for season champions.csv. What is this? League of Legends. How big is this data? It's very small. The whole data set is less than 1 megabyte. So you might be limited just in that fact that it's so small. It doesn't really sound interesting to me. I want to do something that the great Rob Mulla Jose says. Yeah, I'm just me. I'm just me, okay? Similarly, what are you doing? There's also a Chrome extension that makes summary out of the transcript of a YouTube video using ChatGPT. Oh, that's pretty cool. I think that's against the terms and conditions, though, of ChatGPT to write any APIs like that. I don't want to get my account banned. I'm re-rolling to Python from R, so I'm making small steps. Well, small data, small steps, that's good. What do you have here? You have team,
You have player name. One thing I might suggest with this is like match stats. You can do summaries. You can do like a pair plot. Try to make a pair plot with Seaborn. Hey, we got a subscription, Xcode. Thank you for subbing. How long has it been? 5 months, Xcode. Let's spin the wheel for you. Let's spin the wheelie wheel for Mr. Xcode in the house. Cheers to you. Hope you're doing well. I landed on nothing, and instead I'll just cheers to you. I'm
I'll tell you
re-rolling
what, my
by
friend,
the
I'm going to call
intention.
tonight. Thanks so much for stopping by. I do appreciate it, Rail. Hope to see you tomorrow night, Wednesday evening, 8 p.m. as usual, Eastern Standard Time. Thanks again so much for stopping by.